Alrighty guys, let's go ahead and get started with some factoring by grouping. Hopefully this is a review for you guys, but it's going to be a very powerful tool that we have moving forward with being able to factor out quadratics, higher order polynomials, etc. So a big thing that we need to do is we need to remember that polynomial factoring is a method of rewriting a single polynomial as the product, fancy math word for multiplication, of two or more smaller polynomials. Okay, we can use grouping to factor polynomials with an even number of terms. All right, so first thing that we want to go through and do anytime that we're factoring is always make sure we look for a GCF first. That's going to make everything else so much easier. Trust me, find that GCF first. And then later on in this video lesson, I'm going to go and show you how to use this method to do what's called split the middle. That's just kind of the nickname we give it, to factor quadratic trinomials, okay? Which seems weird because you just said we have to do it with even, and a trinomial would only have 3. But I'm going to show you how we split the middle to make it have 4 terms so we can go and do it that way, all right? So let's start by taking a look at a few examples. So in this example, we're trying to factor 9x cubed plus 3x squared plus 15x plus 5. Okay, this is a cubic polynomial because its degree is 3, that largest exponent. It has 4 terms. It's got an x cubed, an x squared, an x, and a constant term. So that's 4 terms. It's an even number of terms, so I can go and factor it by grouping. The first thing I want to go through and do is see, is there a GCF? Well, 9, 3, 15, and 5 are all relatively prime, so no luck there. But what I can do is if I'm going to factor by grouping, I can kind of divide it up into 2 sections. Okay, normally when this is written this way, we can divide it up into left and to right, and we don't have to manipulate too much, all right? So what I'm going to do is on the left-hand side, separate from the entire problem, I'm going to try and figure out what the GCF is. So the GCF between the first 2 terms, 9x cubed and 3x squared, is going to be 3x squared. So what I'm going to do is just from the first 2 terms, I'm going to take that out. So I have 3x squared, and what's left over? Well, 3x and 1. Okay? Over on the other side, this 15x plus 5, I'm going to say, well, what's the GCF over here? All right, so between 15 and 5, I can take out 5. There's no variables that are in common, so I can't take that out. But I can factor out a positive, and you always want to write the sign here, positive 5. And then what's left over? Well, I have 3x plus 1. And then you're going to notice something really interesting, okay? There's a 3x plus 1 here, and a 3x plus 1 here. So 3x plus 1 is actually the new greatest common factor because this has a 3x plus 1, this has a 3x plus 1, so guess what we can factor out? 3x plus 1. And what's left over? Well, I have a 3x plus 2, and I have a plus 5. So 3x squared plus 5, okay? And that, ladies and gentlemen, is the factored form of 9x cubed plus 3x squared plus 15x plus 5. Okay, if you wanted to go and check it, could you multiply those 2 together? Sure. 3x squared times 3x gives you 9x cubed. 3x squared times 1 gives you 3x squared. 5 times 3x gives you 15x, and 5 times 1 gives you 5. It works. Okay, so this is what we call factoring by grouping. Okay, sometimes they're pretty like this. Other times they're going to be a little bit more daunting, like, ooh, look at this one, big, big, scary numbers. But it's fine, because we're just going to go and do the same thing, okay? So the very first thing I want to do is I want to try and see if there's a GCF, okay? I've got 105, 175, 75, and 5. All of those end with the number 5, so guess what? They're all divisible by 5. If you don't know off the top of your head what it is, get a calculator. 105 divided by 5, okay? It works. You get 21. 175 divided by 5 gives you, if I hit the right buttons, 35. 75 divided by 5 works. 125 divided by 5 works. So the GCF is 5. So we're going to take the GCF out of the whole problem. So 105 divided by 5 we said was 21. So this is 21 y cubed. 175 divided by 5 is 35 y squared. Okay. 75 divided by 5 is going to give you 15. Okay. Y. And then 125 divided by 5 is going to give you 25. Okay. So now I'm going to focus just what's inside the parentheses here, okay? Still got 4 terms, can't factor out any more GCFs, but I want to try to continue factoring, so let's see if I can factor it by grouping, okay? So over here, on the left-hand side, what's the GCF? Well, 21 and 35. Probably going to be 7, okay? Y cubed, y squared, can probably take out a y squared. So this is going to end up being 7y squared, and what's left over? 3y and plus 5. Okay, over on the left-hand side, I can go through in 15 and 25, I can take out a 5, but, very important, this is a negative sign, 99.9% of the time. if your third term is negative, the GCF needs to be negative, okay? 99.99% of the time. So because this third term is negative, I want to factor out a negative GCF. Remember, that means I'm going to be changing some signs. If I factor a negative 5 out of negative 15y squared, I'm going to end up with a positive 3y. If I factor a negative 5 out of negative 25, I'm going to end up with a positive 5, okay? So I'm doing that because my GCF over here was 5, all right? So that we can keep things kind of consistent. Let me go ahead and grab that, and we'll slide it down, and then we'll go back over here, and we'll write out that the GCF on this side was negative 5, okay? Again, that negative being important because the third term was negative. So looking at all of this super fun stuff now, do I have a 3y plus 5 on the left-hand side? I sure do. Do I have the same thing, a 3y plus 5 on the right-hand side? I sure do. So guess what that must be? Some sort of common factor. So I have 3y plus 5, okay? What are the other bits and pieces that I have left over, okay? I have a 7y squared minus 5. And then very importantly, I also need to remember that I factored out a 5. So guess what I also need to include as another factor? That 5, okay? Because technically speaking, it's 5 times all of this stuff, okay? So this represents the complete factorization of this 105y cubed plus 175y squared minus 75y minus 125. We find the GCF of the whole problem, take it out because it's going to make easier math moving forward. GCF of the left two terms, factored out. GCF of the right two terms, factored out. Then we can factor by grouping because we're factoring out those common groups, and we got ourselves a solution, okay? So what if things get real weird, like the 6AW minus 36AK plus 6B squared W minus 36B squared K? There's too many letters in there. You're not even spelling words. Can I buy a vowel? But it doesn't really matter. We do it the same way, okay? Can we find a GCF of the entire thing first? 6, 36, 6, 36. Yep, I can probably take out a 6. This one has an A and a W. This one has an A and a K. This one doesn't have an A. That one doesn't have an A. So all we can take out is a 6, okay? So let's factor a 6 out of everything. So it's really just 1 AW minus 6 AK plus 1 B squared W minus 6 B squared K. All right? So now I can go and try and do some factoring by grouping again. Okay? So what's the GCF of 1 AW and negative 6 AK? Well, just A. All right? So what's left? A W and minus 6K. Over on the right-hand side, what's the GCF? Well, this one's got B squared W. This one also has a B squared, so maybe I can take out a positive B squared. And what's left over? Well, 1W, otherwise known as just W, minus 6K. So, do those two factors match? W minus 6K, W minus 6K, they sure do. Must be one of my factors. So W minus 6K. What are the other bits that were attached to those factors? Well, A plus B squared. And then, did I have this 6 that I factored out at the beginning? So let's make sure that we include it when we are writing our final answer as well. Okay, so those are all kind of big polynomials that we can factor. All right, so with factoring by grouping, now I'm going to show you how we can actually apply this to factoring quadratic trinomials, specifically the ones that have a leading coefficient that's greater than 1. So this method we just kind of call split the middle, and the reason we do that is if you look at this first example, it is a quadratic because it's got a degree of 2, but it's a trinomial. It's only got 3 terms. So how are we supposed to divide it into kind of like 2 equal sides if, you know, it's got 3 terms? So we're going to actually find a way to rewrite the middle term as the sum or difference, plus or minus signs, of whatever will equal 5. So let me show you how to go through and do that. So the first thing we're going to do is take a look at the leading coefficient 12 and the constant negative 2. And I'm going to go and multiply those two together. 12 times negative 2 is negative 24. Okay, so what I'm trying to do is I'm trying to figure out what are factors of negative 24 that when we add them together, we get 5x. So I'm thinking that maybe 8 and 3, because 8 and 3 make 24 and they could make 5. So it would have to be a positive 8 and a negative 3. Okay, so I'm going to go ahead and say that it's also going to include x's there. All right, so now what I can do is I can rewrite this trinomial as a 4-term polynomial. So I'm going to write it as 12x squared plus 8x minus 3x minus 2. So the 12x squared stays the same. Minus 2 stays the same. But instead of writing 5x, we're writing positive 8x minus 3x. Will that simplify to 5x? Absolutely. Okay, now I can go and factor it by grouping. So it's the GCF between 12 and 8, 4, between x squared and x. So what's left over? Well, I have 3x plus 2. Okay, over here, the GCF between negative 3 and negative 2 is really just 1. But remember, because that third term is negative, we want to factor out a negative. So if I factor out a negative 1, I have 3x plus 2, okay? Remember, when we factor out a negative, it changes the signs. So does this match this? It sure does. So that tells me that this is going to factor into 3x plus 2, and I'm going to be able to multiply that by 4x minus 1, okay? Remember, from these parts right here, 4x minus 1. So this represents my factorization. Could you go through and check that? You absolutely could. Okay, so what we could do here is we could multiply these two together. So 3x times 4x is 12x squared. 3x times negative 1 is minus 3x. 2 times 4x is plus 8x. And 2 times negative 1 is negative 2. Okay, so are you going to get 12x squared plus 5x minus 2, just like the original problem? Absolutely. So we can use this split the middle technique to be able to factor a quadratic trinomial with a leading coefficient that's greater than 1. Right? So let's take a look at a couple other ones real quick like here. Okay. So if we start with this first one, we've got 6x squared minus 11x plus 4. Okay, it's a quadratic, it's a trinomial, it has a leading coefficient greater than 1. So let's start by trying to multiply those together. Okay, so multiplying the leading coefficient and the constant, 6 times 4 is positive 24. Okay, now we got to think, what are factors of positive 24 that combine to negative 11x? Well, a negative times a negative is a positive, so maybe negative 8 and negative 3, because 8, 9, 10, 11, yeah, that'll go through and work. So I can rewrite this as 6x squared minus 8x minus 3x plus 4. Okay, and then I can go and do some factoring by grouping. So I'm going to go ahead and split it right down the middle there. So over on this side, the left side, I'm going to take out the GCF of 2x. What's left? 3x minus 4. Over on the right side, I have a negative value first, so I probably want to take out a negative. 3 and 4 are relatively prime, but I can always take out a negative 1. So then I've got 3x minus 4, because remember, when I factor out a negative, I change the signs. So do I have a 3x minus 4 here and a 3x minus 4 there? Sure do. So 3x minus 4. And then what else do I have? This 2x, this minus 1. So I also have 2x minus 1. And if I multiply those two together, am I going to get 6x squared minus 11x plus 4? I absolutely will. Okay, one more for us to take a look at. Okay, 15x squared minus 84x minus 36. Right? So maybe this one has a GCF, and I would guess that it probably does because those are all relatively big. Do I really want to go and multiply 15 by 36 and then find factors that combine to negative 84? Probably not. So let's see if we can find a GCF. So if we look at 15, we got 5 and 3. 84 and 36, not divisible by 5, but maybe by 3. Use a calculator and check. 84 divided by 3 gives you 28. So guess what I can do? I can factor a 3 out. Okay, so this becomes really 5x squared minus 28x, and then minus 36 divided by 3 is going to give you 12. So those numbers are a little bit smaller, a little bit easier for me to go and contend with. All right, so now I still have a quadratic trinomial with a leading coefficient greater than 1. So I'm going to go and multiply those two together. Okay, 5 times negative 12 is going to give you negative 60. Okay, what are factors of negative 60 that'll get you negative 28? Well, I would guess maybe like 30 and 2. Okay, but to get negative 28, it'd have to be negative 30 and positive 2. Okay, if I multiply those two things together, I'm going to get negative 60. If I add and subtract them, I'm going to get negative 28. So I'm going to go with that's what I should be using. All right, so I'm now going to go through and say that this is really 5x squared minus 30x plus 2x minus 12, and I'm going to try and factor this by grouping. Okay, so the GCF over here on the left is probably a 5x, and I'm left with x minus 6. Over here, 2x and negative 12, I can probably take out a positive 2, and I have x minus 6. So do those two match? Absolutely. So I've got x minus 6 as one of my factors. Okay. The other one is going to be 5x plus 2. But before I put a box around it and say I'm done, let's please, 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 please not forget that we took this 3 out at the very beginning. So let's add it in there at the end. So we have all of the factors listed out. Okay? So to recap, when do we use split the middle? When you have a leading coefficient that's greater than 1. Okay? How do we use split the middle? Well, you take the leading coefficient and you multiply it by the constant. That gives you a number. What are factors of this number that will add up to your old middle term? This is how you're splitting that middle up. In this case, it was negative 30 and positive 2. So then we rewrite the trinomial as a 4-term polynomial so that we can go and use factoring by grouping.